With this video, I want to just show you guys an example of what the substitution technique looks like when it's all written out by hand, when you show all of your work, the same way I would expect you to show your work when you're doing this on, say, the final exam. Like I said before, that first video on substitution, that one involves a whole lot of fancy camera work or editing or whatever, where you don't necessarily see what it would look like if it were written out. So hopefully this helps you see what kind of work I would expect. And if you watch the next video, our very last video, for section 5.6, where we're doing these substitution with definite integrals, you'll see more examples there of what this all looks like when you write it all out. All right, so here, if you feel like you understand from the first video how the substitution technique works, you may want to pause the video here and try this integral on your own. So I'll let you do that, and then you can press play and see how you did. All right, so the way I like to handle this is I'll just write all of my substitution information over on the side, and this is work that you would need to show as part of the process. The idea is that this integral is something that we don't know how to do the antiderivative for right off the bat. So our technique that we're going to try here is the substitution technique, because really it's the only technique that we know right now. You'll learn more techniques in Cal 2 for those of you who go on to Cal 2. But for substitution, how do we pick the appropriate thing for you? There's a few things you look for. One thing you look for is the derivative of some piece showing up somewhere else. The other thing you look for is maybe a composition of functions where you have some function on the inside. And with those two things in mind, looking at this integral, first of all, I see a composition of a square root function with a tangent function. And so maybe tangent would be a good option. There's other things you may have tried, like maybe you'd start by saying, well, what if I let u equal 5x? Does that help me? Maybe it helps a little bit, but you may not have gotten anywhere meaningful with that substitution. You would still need to do a little bit more work. So when I look at this, the thing I'm going to try, I don't know, we'll see how this works out. I'm just going to pick something and go with it. I'm going to try tangent of 5x, this whole thing under the square root. The reason I'm picking that is, yes, it's part of a composition of functions that's inside the square root. But more importantly, the derivative of tangent is secant squared, and I see a secant squared showing up. All right, so that's kind of my big indicator here that u should probably be this tangent function. All right, so I'll say u equals tangent of 5x. And when I do the derivative of that, the derivative of u with respect to x, well, we know that the derivative of tangent is secant squared, but I have this 5x on the inside. So I have secant squared, and leave that inside function alone, that 5x. But if you remember the chain rule, to finish this derivative, I have to multiply by the derivative of that inside function, so times the derivative of 5x, which is 5. And then, like you saw in the previous video, we like to move this dx over to the other side. So we write this as du equals secant squared of 5x times 5 dx. And right here, this tells me that I'm probably on the right track because I've got the secant squared 5x dx showing up over here, and I've got a secant squared of 5x dx showing up in my integral. The only thing that doesn't match here is this 5. So I want to get rid of that 5, and I can do that pretty easily if I divide both sides by 5. So secant squared x or secant squared of 5x dx. If I'm dividing both sides by 5, this 5 is gone from the right-hand side, but I have a 1/5 du on the left-hand side. All right, so now everything is accounted for in my integral. The secant squared 5x dx is going to turn into a 1/5 du. The tangent x is just going to turn into u. All right, so what this integral looks like after my substitutions, the square root of tangent 5x, but tangent 5x is being replaced with a u, so now I just have the square root of u. Secant squared 5x dx, like we said, turns into 1/5 du. Basic properties of integrals tell me I can just bring this 1/5 outside of the integral and not worry about it right now for my antiderivative. Now I just need to know the antiderivative of the square root of u with respect to u. If we're doing antiderivatives, we don't like square roots, so we probably want to rewrite this as 1/2 power. All right, and now I'm doing the antiderivative of u to the 1/2. That's just a basic power rule, the antiderivative version of the power rule. So I need to add 1 to my exponent. U to the 1/2 plus 1 is 3/2. And then I need to divide by that number, 1 over 3/2. And anytime we do an indefinite integral, when we do the antiderivative, when you get this arbitrary constant tagged on to the end, so plus c. Now there's 2 things here I need to do to finish this up. First of all, 1 over 3/2, that's kind of ugly. Let's write that as 1 divided by 3/2 is the same thing as 1 times 2/3. But then 1/5 times 2/3 is 2 over 15. All right, so I've got 2 over 15. Now, the last thing I need to do, your final answer should be in the same variable as your original integral. My original integral, the variable was x. My final answer needs to be in terms of x as well. All right, so if you try to stop here with a u to the 3/2, you're not going to get full credit, or on your homework, it's just going to count it wrong, and then you'll have to go through and try it all over again. Okay, so your very last step, anytime you do a substitution technique with an indefinite integral, is to undo the substitution. I don't want a u in my final answer, so I go back over here, u equals tangent of 5x. So I return this back to its original form. This is tangent of 5x to the 3/2 power. All right, so we just undid our substitution. If u equals tangent of 5x, then I replace u with tangent of 5x, and now I've got back the original variable that I started with, which was x. And now this would be my final answer. One thing that you'll notice in the next lesson, when we're doing this with definite integrals, you'll see that we actually don't have to do this last step of undoing the substitution, because we make adjustments to the bounds on the integral where it's okay to leave things in terms of u, because, well, you'll see that in the next video. But anytime you're doing these indefinite integrals in this section, always make sure you undo your substitution at the very end. All right, now, again, the main idea of this video is to show you what your work should look like whenever you're writing out things, say for a test. Because again, that first video had some just editing where it's not as clear how things should look. But hopefully this shows you what I would expect. You need to show all of the work over here on the right. You need to show what substitution you're making. And with that substitution, you need to work around with this to figure out what this du turns into and figure out how to get this secant squared 5x dx. You need all of this stuff over here to explain how you get from this original integral to this integral in terms of u, okay? So all of this stuff explains how to get from the first integral here to the second integral. And then from then, it's just, from there on, it's just basic antiderivatives, all right? And then after you finish your antiderivative, last step is undo the substitution, and then you're done. All right, hopefully that helps. Please reach out to me. Let me know if you guys have any questions over this homework.